Everyone, welcome back. We saw for the value of x given this algebra problem, we have x cubed plus x is equal to 68. So what is the value of x? Solution. So we have x cubed plus x. This is supposed to give us 68. Okay, so taking 68 to the left hand side, we'll have x cubed plus x minus 68. This is equal to 0. Okay, so that we'll have x cubed plus x minus, now 68 can be expressed as 64 plus 4, which is equal to 0. Okay, so that we're going to have x cubed plus x minus 64 minus 4. This is equal to 0. So that we can write 64, can express 64 as 4 cubed minus 4. This is equal to 0. Okay, so now you can see we have x cubed and 4 cubed, so we can put them together so that we'll have x cubed minus 4 cubed plus x minus 4. This is equal to 0. Okay, so you can see clearly that the first part, this is the difference of cubed expressed as a cubed minus b cubed, which minus b cubed is equal to a minus b, a squared plus ab plus b squared. Okay, so we have x cubed minus 4 cubed, which is equal to x minus 4, x squared plus 4x plus 16, so that we'll have x squared, okay, plus 4x plus 16, okay, plus x minus 4. This is supposed to give us 0. Okay, so we have x minus 4, x squared plus 4x plus 16 plus x minus 4 is equal to 0. Okay, so x minus 4 is common, so that we'll have x, we factor out x minus 4, so that we'll have x squared plus 4x plus 16 plus 1. This is equal to 0. Okay, first root at x minus 4, which is equal to, that means that x is equal to 4. Okay, so that now we have the quadratic equation expressed as x squared plus 4x plus 16 plus 1, which is x squared plus 4x plus 17. Okay, so with a equal to 1, b equal to 4, and c equal to 17. Okay, now to solve for the value of x, first of all, you find that this quadratic equation has a discriminant value which is less than 0, expressed as b squared minus 4ac, which is equal to 0. So this is equal to 4 squared. Substituting, we'll have 4 times 1 times 17. This is equal to 16 minus 68, which is negative 48, which is less than 0. So that means that we have two complex roots. So, and so for these two complex roots, remember they're in the form of x1, which is equal to a plus ib, and x2, which is in the form of a minus ib. Okay, so these two complex roots are in that form. And to solve for x1 and x2, so for x1 and x2, we apply the quadratic formula expressed as minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so we just substitute the values of a, b, and c. Okay, so that we have minus 4 plus or minus the square root of 4 squared, that's b squared, minus 4 times 1 times c, which is equal to 17, divide everything by 2, multiplying by 1. Okay, so that now we're going to have negative 4 plus or minus the square root of 16 minus 68 divided by 2, so that we're going to have negative 4 plus or minus, now this is negative 48 divided by 2. So that we'll have negative 4 plus or minus the square root of, now this negative 48 can be expressed as 12 multiplied by 4 multiplied by negative 1 divided by 2. Okay, so this is negative 4 plus or minus, now 12 again can be expressed as 4 multiplied by 3 multiplied by 4 multiplied by negative 1, divide everything by 2. Okay, so that we're going to have negative 4 plus or minus, now this is 4 times 4, which is the square root of 16, multiplied by 3 multiplied by negative 1, divide everything by 2. So that we'll have negative 4 plus or minus, now this is the square root of 16, which essentially is going to give us 4 multiplied by the square root of 3, square root of negative 1 is I, divided by 2. So that we'll have negative 4 divided by 2 plus or minus 4 divided by 2 square root of 3i. Okay, so if you simplify this, we're going to have negative 2 plus or minus 2i square root of 3. Okay, so that means that x1 is equal to negative 2 plus 2i square root of 3, and x2 is equal to negative 2 minus 2i square root of 3. Now these are two complex roots. These are two complex roots, or rather the imaginary roots. Now that means that our real root, which is x, remember we end x equal to 4. Okay, so this is the only real root that we have. Okay, that's the only real root that we have. And x1, which you have seen, is negative 2 plus 2i square root of 3, and x2, which is negative 2 minus 2i square root of 3, which are the imaginary roots. So we have 3 solutions, but now we have our real root as equal to 4. So let's verify if this value of x, which is equal to 4, satisfies the equation. Remember, the equation is equal to x raised to power 3 plus x is equal to 68. Okay, so that we're going to have 4 cubed plus 4, this is equal to 68. So 4 cubed is equal to 64 plus 4, this is equal to 68. Okay, so that we'll have 68 is equal to 68. So that means that the left hand side is equal to the right hand side, and that essentially proves that is x is equal to 4. That's with the other two solutions. That's the complex root. Thank you for watching, and kindly subscribe.